join in. To give you an idea, I joined in the team led by Chris Webb, the European team, and I was the second person to join. And now we are a team of, I think we're 10 people now in Chris's team. So we've grown significantly. If I do have any spare time, I try to engage in a Belgian user group, which does very similar things to this. We organize sessions, online, in person, conferences, boot camps, all those things. If you want to reach out to me through any of the social channels, you can find me. If you can spell my name, I'm really easy to find, but spelling my name correctly is something that usually isn't the easiest thing to do for multiple people. And I'm not even going to ask you to pronounce my name, especially my last name, because that's where it usually gets butchered. What we're doing is we're going into a session on troubleshooting. And I want to make sure that you're aware, I mean, you're probably well aware of these options that exist for pinpointing common causes. People are saying, my report's slow, this doesn't work, Power BI is rubbish, it doesn't do what I expect it to do, so that we can pinpoint these actions, and then from there on, we can take the actions to do it. But pretty much, it is also a hidden agenda for best practices and techniques to make sure that you can avoid a lot of these issues to come up. One of those things, I'll give you a big spoiler alert, is star schema all the things. Star schemas are what makes Power BI thrive. And that is something that very often comes back as well. And in the end, it boils down to a usable set of best practices. But I do want to mention explicitly that this is not a DAX or a Power Query Performance Deep Dive. In fact, I'm not even touching any of those two. It is purely on modeling and then the report authoring experience, because that's where you can do a lot of harm if you're not aware of a few things. A lot of the time, people come up to me and say, yeah, the DAX is too slow or Power Query isn't performing well, but they end up doing weird things inside of their report, which is actually making that report slow itself. So that's what we're focusing on, and not DAX and Power Query. But in the end, I mean, it depends. I'm a consultant by trade, so that means that usually any answer that comes up in this session is it depends. It's a horrible answer, but I will do my best to try and give you an actual answer on this. But why do we actually bother troubleshooting? Because no one likes to wait. That's as simple as it is. No one likes to wait. Myself as well, when I see the horrible spinny wheels of death that take about 5, 6, 7 seconds, I get anxious because I want to see my data and I want to see my data now. And that's the whole reason why we troubleshoot these reports, because usually when they're slow, that leads to dissatisfaction from end users. They'll drop off. Maybe they'll just export it to Excel and then go on their own way doing everything there. But also, I mean, what I've often heard from working with developers that created said reports, they said, yeah, but it works fine on my machine. And it is not a valid reply, because there's a lot of factors that come into play when we're working with different types of machines. And the end user hardware is also very important in this context. But we also need to realize that the context and the baseline are key. And what I mean with those is, are we looking at a report that is querying millions and millions of data or gigabytes of data, and do they expect the return to come back in under 3 seconds? Or is this an Excel file that has 15,000 records in it and they want to see it at the snap of a button? What's the expectation? What is the volumes of data that we're working with? And what are they actually trying to do? That is also something that's really important to understand. Typically, when I go in, especially in the days where I did longer consulting engagements, I always went in for quick wins on the heavily used reports. One, so that users and the business people see progress, you gain their trust, so that you actually have something to report back on and that you get some more time to dig into the deeper issues. If you disappear into a damp basement for 3 weeks and then come back with nearly nothing, that's not going to do you any good, nor usage of your actual reports. And then typically, I try to avoid those long investigations on reports that barely ever get used, unless it's C-level reports that they have to use on like the end of the quarter close or something. But typically, I always try to go for reports that are actively used, where you can get the most gain out of them. And in the end, I mean, it's not a scientific formula. It's a mixture of knowing what to do, the scientific part, having a certain flair about it, and it is also sheer dumb luck. You cannot know everything. It's impossible to know everything. It's good to want to learn new things, but sometimes you also have to have some luck in things you're trying. I mean, and that's perfectly acceptable. But yeah, it depends. Sorry. But before I go on, there is one concept that we need to be aware about, and it's the concept that is called noisy neighbors. And essentially, noisy neighbors means that when you're sharing a Power BI environment, it's possible that there are other reports, there are other models, there are other users using up resources. And that means that you will never ever get the exact same performance metrics if you run things 2 times, 3 times, 4 times. It can also mean that sometimes it can mean that your report is going a bit slower because of the fact that there is a heavy load, especially, I'm not diving too deep into this, especially with Power BI Premium Gen 2, if there's throttling involved because of overloading, etc., that means that an end user can be impacted on this. But throttling and overloading is good for another 60 minutes, so I'll park that right here. But it is important to be aware that there are a lot of factors, a lot of variables into play when you're trying to benchmark these things. So these shared resources for Power BI, they're a blessing and a curse. Wow. If you're working on Power BI Pro on the shared capacity, that means that you're essentially working with all people, all tenants in that same region. That means that potentially there could be very high load at that point in time. The beauty of it is that the service manages most things for you. You don't have to worry about when you're scheduling refreshes, etc., because that's all figured out by the service. Within Power BI Premium, the first thing that I heard was, okay, yes, this is automatically going to solve all the performance issues we have because we have dedicated hardware. And the thing is, the reality is that it was actually the opposite, because at that point in time, you had to start thinking about when you're doing which things. When are you scheduling refreshes? Because everyone usually schedules their data set refreshes in the middle of the night. And then that's something that you had to start thinking about. And then we moved on to Power BI Premium Gen 2, which is a very good improvement. It's massive improvements opposed to Power BI Premium Gen 1, but it's still not a one fix for all. There are still some things that you have to think about when you're actually trying to schedule larger numbers of data set refreshes, when you're trying to make data available for a larger organization. And then in the end, we also have to be aware of that things called caching mechanisms. And caches exist on many different levels. They can be on a visual level, on a query level, result sets get cached. There could be caching on the data source itself. Caches are everywhere. And it's something you need to be aware of because, again, if you're trying to benchmark performance results, you will never ever get 2 times the exact same. Well, you shouldn't always get the exact same results back. There's always going to be a small difference when you're running the same query 2 times. So myself, I wanted to have some reports, some demo data, and I didn't want to use the AdventureWorks, or was it the worldwide importers these days, or the Contoso. I wanted to have something different. So I was looking for data sets, and I stumbled upon the public bike sharing station in Antwerp, the city where I went to college. And they have a bunch of these bikes where you pick them up, you drive around town, you put them back down somewhere. So that data is all logged somewhere. I asked for the data points, but I would only be able to get the aggregated data up to a day level, which wasn't what I actually needed. So I went further into it, and I went into the New York City bikes data set. And it's the same thing, but only a lot bigger. There's a lot more bikes driving around New York City than there is in Antwerp. And they make this data available for everyone to download freely. So it is a good data set. I think if you have the entire thing, you're up at about, what is it now, 120 million records now, which is a good data set to start doing some testing with. But I created a report, and Carrie, please don't kill me, because it is the pinnacle of report design. But it is a report that is mainly doing some things wrong so that I can try to explain it. So we're actually already seeing a bunch of spinning wheels of death. And because I'm running Teams, it's now going to be even slower. Usually this renders completely in about 20 to 30 seconds, but I think it's going to be a bit slower now. So there are a lot of things happening on this report. And it is the types of reports that I actually see come back from customers, from other people that have designed reports. And they're not necessarily bad, but there are things happening with it that can be improved upon. And that's where we're going into. And it is really taking a long time now, which is, yeah, not that good. But it means that there's some things happening that I want to go into. And we're going into a few steps outlining just purely on the report itself what we can do with this. But it is a report that I basically just wanted to show because there's a bunch of cards happening, a bunch of card visuals here. We've got a graph, a beautiful line graph. We've got a map. And then somewhere in the next, hopefully seconds or so, there's going to be a matrix with pretty much all the data down to the lowest level of granularity, which is something that I sadly also run into very often, where you've got tables and matrices that pretty much have all the data in it because they want to use all that data. And then most of the time also export it to Excel, which is, which is something that I also don't like that much when people just try to export things out of Power BI so that they can go and do their own thing afterwards. I'm going to skip waiting for the graph, the matrix to render. I think I've made my point here. And then, here we go. Let's go. There we go. Before I actually go into the troubleshooting, there is something that you need to be aware of because I now run Power BI Desktop. It's the little desktop application. It runs beautifully on Windows. It doesn't run on Mac, as Phil mentioned in the social hour before this as well. But there's a lot of things happening under the covers. And it's a bit of a mixed bag because we've made some changes, and we're actually, I'll dive into those changes as well. We need to look at two things here. And that's where we're using CPU time. That's where we're using memory time. And then there's a lot of things happening. We've got the desktop application itself, the executable. That's what you actually see. That's the Canvas application. That's what you interact with. And there's a bunch of Microsoft mashup evaluation containers, and they are Power Queries running. They are processes designed to transform the data, everything that you're doing inside of Power Query. Then we actually have a Microsoft Analysis Services instance running every time you open up a Power BI Desktop instance. So it is an instance of Analysis Services that gets spun up every single time you open a Power BI Desktop. It has the full feature availability set in there, and as soon as you close the PBIX file or the PBIX, depending on how you want to pronounce it, that also closes down that Analysis Services instance. And then a bunch of browser sub-processes. We don't need to make too big of a deal out of it because it actually is in the process of changing. And then we also have a console window that ties the entire thing together. David, do those mashup containers stay there the whole time while the desktop application is running? I think they do, actually. I think they are still there, but they don't necessarily use the same amount of resources. But I actually never actively checked it if they disappear after a time, because this screenshot was taken at a point in time where the data was loaded. So that does mean that they are most likely there, but it's something that I'd actually have to follow up on to see if they disappear at a given point in time. So as I mentioned, there are some changes that are being made, and it's the infamous WebView 2. I heard the transition wasn't completely smooth. There were some issues with it. And then, oh, I'm sorry, Kerry, I missed your question. It is indeed the M code, the Power Query transformations. So with WebView 2, a lot of these browser C# sub-processes that you've seen, they're all now contained in the Microsoft Power BI desktop functions that you're seeing here. But in the end, nothing's actually changed. They're still the same types of processes that are running, and they still use the same types of resources. So we've got Power BI Desktop itself, the Canvas application, Analysis Services, the Power Query transformations, and then the background operations running the entire thing. And that's what we need to be aware of, is that there's a lot of things happening. So it's not just you open up an application like Excel and it's not just doing some weird little things. There's actually a lot of magic under the covers that do things for us. But whenever I need to start troubleshooting these reports, whenever someone hands me a report, that's when I need to go look into my tool belt. And then if I look into my build, there are a lot of things that commonly appear back into it. And the first one is coffee. I don't troubleshoot reports without a cup of coffee. Sorry, that's not how I roll. It is the most important tool of all. And then, yeah, there's no working without that. But other than that, I mean, the beauty that we have these days with a vibrant Power BI community, that so many different external tools exist, is that there are tools that are capable for let's call it for specific scenarios and situations. But most of the time, I'm saying most of the time, I'm actually containing myself to, I'm actually just sticking to the 4 on the top, well, actually 5 on the top. And those are the ones that I'm briefly covering today as well. The other tools, like I said, they all have specific scenarios and they come up less. With the 5 on top, that's where I can do, let's say, 95% of the things that I need to be doing. But like I said, the beauty of the Power BI community that we have is that these tools are made available. They're mostly all open source, and most of them are free. The only exceptions that we have that are not free is Power BI Sentinel and then Tabular Editor 3. But for Tabular Editor, there's still a free open source version of it, Tabular Editor 2, which means that you can still use it completely for free. The first one, and that's the most important one, that's the Performance Analyzer Pane. It came into existence in about May 2019, and it's essentially a flight recorder for all the operations that you're doing, that are now happening inside of the Power BI desktop file. It can break down the execution times into what's actually happening. So you can get an overview of what's the DAX rendering time, if you're running data query, how much time is spent on doing the data query operations, the visual rendering. Those are all included in there, and you can sort them, and you can also export these results. But let's jump into this one. And if I go back into the report itself, this is the same version of the report that I had open, but I opened up 2 versions so that I can actually explain something here. Because when you're going into the Power BI Performance Analyzer pane, you do need to be aware that the second you open a Power BI desktop and something is rendered, a visual, a graph, whatever, that gets loaded into the cache as well. So if you open up Power BI Performance Analyzer pane after you've rendered the first things, you're going to see better results as you get from the initial loading time. So what I've got here is a blank page, something else to fall back on. That's where I can actually enable the Power BI Performance Analyzer pane so that we can get the, let's call it the cold start of the visuals, that we can look into these things. So if you want to do this yourself, if you want to start up with the Performance Analyzer pane, add a blank page into the Power BI file, save it, close it, open it up again. And that's when you can get the same results as I have right now. So going into this, I can go into the view pane and then say I want to use the Performance Analyzer pane. The Performance Analyzer pane pops up, and that's where I can start actually recording the data that I need to have in there. So the second I start to record, everything that I'm doing now, every click that I'm doing on tabs or on visuals that cause interactions, they're going to be logged inside of this pane. So let's say if I go into the card, into the same report that I had before, this is where all of these things are happening. So I can see that there's a breakdown happening here of the different types of visuals that I had. So the different slicers, the cards that I all had, and they get depicted with the execution time that's been happening there. So while a bunch of these are rendering, there's some things happening, and some things that we need to be aware of as well. Because for instance, we've also got a bunch of shapes here, and they all get rendered by Power BI itself as well. And that's something that to date, still a lot of people seem to forget about, that every single little text box, graph, line, everything that needs to be rendered also takes time to render. And then Power BI only can handle a limited number of operations at the same time. So it's essentially trying to work its way over a large number of visuals, and it needs to wait for other visuals to be done. For instance, if I open up one of these visuals here, the shape, it should render fairly quickly. We would all expect it to be rendered in less than a couple of milliseconds. But because of the fact that we have something called other here, that's how we can see that it's actually waiting for other visuals to be done rendering. And it means that for 1.6 seconds of a time, it was waiting for its turn to be able to be rendered. And then I'll be honest, 1 second for loading and rendering a visual for a simple shape is a long time. But you need to be aware that my trusty work device isn't the best, and I still need to switch to the virtual desktop ones, Phil. I still need to do that. And it is running slow in combination with Teams, which makes the whole thing render a bit slower as well. But it's waiting for other operations to be done, and then it's doing the visual display. But if I go into one of the actual card visuals, for instance, that's where we're seeing other things happening. In the card for the average duration, for instance, we're seeing that 33 seconds of the time it's spent waiting on other things. And then for rendering the visual itself, it took 40 milliseconds. The DAX query only took 500 milliseconds, which isn't great. I'll admit that, but it is showing us many different things. So how do I decide what do I focus on? Well, that's where I'm actually going into. The matrix is still rendering, so I'll leave that be. But you can also go into the sorting window, and that you can say is, okay, I want it to be ordered by the DAX query or by the visual display, and show me the ones that are taking the longest time, for instance, to render the visual. So if I pop that over, yeah, Kerry, that's what you get with overly detailed matrices. So if I put it to order by the visual display descending, then usually that's what I'm going to see up here is the map. That's usually what I'm seeing up here. There we go. So deciding on which of the visuals you specifically want to tackle can be easily done by going into the sorting window and saying, I want to see the heaviest DAX queries first. I want to see the visually intensive visuals first, etc. And that's how you can start determining which of the ones you want to be looking at. But I did say that there are a couple of things happening in here that I want to be looking at. And it means that I want to make sure that we go into things that can be easily done in Power BI Desktop itself without looking at different types of external tools. So for a completely non-scientific reason, I tried to explore how slow I could render a Power BI report that doesn't actually have any data in it. So it is connected to this Power BI data set, but there's no actual data being used on the Power BI canvas itself. And it is something that I did to explore how performance degrading a large number of shapes can be. Okay, so I did. Yeah, so I'm trying to switch over to the tab, which probably is doing right now. But it is essentially a tab where I have about 250 shapes in there. And these 250 shapes is basically a report that's running without any data in there. And that takes about 3 to 5 seconds to render when I'm not doing anything else. So that means that just by adding a bunch of shapes on there, things that have no data, lines, text boxes, shapes, rectangles, whatever you want to do for the visual appeal, there we go. That render is incredibly slow as well, just for the fact that it is individually for every single one of these, it is just doing something, one operation at a time. So about 16 seconds were taken just to render all of these shapes. And does this have a valid business case? No, it is just something that I try to do to make people aware of the fact that adding many different shapes in there can be not so great as well for your end user experience. So if I change that over, for instance, to a different view where I'm saying I'm reducing the clutter, where I'm taking away all the different types of shapes, then that typically leads to a report that's going to be a bit quicker as well. It's rendering faster. The thing is, we do have to be aware that most of these visuals are the same visuals, the exact same visuals as that were on the other graph, on the other canvas tab. Because of the fact that they already executed, they are hitting the caches and the results are coming back fast. So that means that we are running faster, but we don't need to overestimate the impact that it had of reducing the clutter on these. And then I usually get the question of, yes, but we still want to have shapes on this. We still want to see pretty backgrounds, etc. Which is okay. I'm not going into the debate of Power BI report design on this, but typically, if you have designers that still want to do this, the point of advice that I typically give them is to look to whatever design interface you prefer. Some people do it in PowerPoint. I've seen people do it in Illustrator. I've seen people do it in Paint, whatever. You can make a single image that lists the background that you're trying to use. If you do this approach, then that means that you only need to render one image instead of potentially upwards of 10, 15, 20 different images. And that's how you can easily shave off a second, 1.5 seconds of the initial loading time of your report. Is it an ideal solution? No. Is it something that you might want to think about if you're looking at a larger report and you want to get the report performance to be a bit better? Yes, absolutely. Then I have the overly detailed matrix is still going. It's going strong, but I also have a bunch of individual cards here. And what we need to be aware of inside of Power BI is that every single visual that I have on the canvas sends at least one query back to the underlying engine. I'm saying at least. It means that there are certain visuals that can send multiple queries to the backend. It also means that usually when you're doing certain DAX operations, that other types of operations are happening, and these are things that you want to take a look at, because again, Power BI can only do so many things at a time. If you're sending multiple little single queries back to the database and to the analysis service engine, that means that you're going to have waiting time. So I think I have about, what is it? I keep forgetting the number. I think I have about 17 individual cards here. That means that there's 17 queries to send to the backend. If, for instance, I were to collate them into single visuals, that means that there would be less queries run, and they're typically also evaluated faster because of 17 little individual queries or 3 still small queries that are being executed. So if I switch over the cards to a table, for instance, or a matrix, and play around a bit with the formatting, you can still get the same type of look and feel. But typically, this also leads to the fact that your report is going to be executing faster because of the fact that it has to send less queries to the database engine, to the backend engine, sorry. And it is something that you need to be aware of. If you're using a lot of individual card visuals, small individual visuals, that can lead, as I said, to a lot of different queries being sent. You have to wait until the results get back, and typically just wait for things. And a general rule of thumb with anything working with data is the less number of visuals, the less number of queries you have to execute. That typically means that your report, your overall look and feel, your performance is typically going to be a bit quicker. Then the next one I want to tackle is the overly detailed matrix, because right now you still haven't seen that render. It always goes down. Well, it always keeps seeing the spinning wheel of doom. And that is purely because of the fact that I put every single transaction in there to the lowest level of detail, to the lowest level of dates, to the lowest level of the station name that I'm working with. And there are a couple of reasons why I don't typically like this approach. The first one is, what are you actually going to do with a table that has, let's say, more than 1,000 rows in there? You cannot process it. You cannot process this with, the human mind has issues processing this amount of rows, especially if you're working inside of a Power BI visual. It's going to be harder for you to get the actual information out of there. If you really, really, really want to have big chunks of tables, then my suggestion is to look at Power BI page generated reports, reporting services, if you will, or analyze in Excel. That's where you have the tools that are better equipped to deal with large tables. The second thing is, because you're getting a lot of data to the lower level of the domain, to the lowest level of the granularity, that means that it's sending a heavy query back to the backend engine. It's sending a heavy query back to the analysis services engine. And it doesn't have to be, well, it doesn't have to be this big or this hard of a query to be executing. So what you can do is if you actually want to have the low level of granularity, typically you need to make sure that you filter down the data, that you limit yourself to a certain time span or a specific station, etc. Maybe even do it with a drill through experience from another Power BI report page, whatever you can do, but making sure that you can filter down the data so that it's processable by humans and that the query is a bit more optimistic as well to be sent back to the backend engine. That's typically something that's going to be very good to do. So if I go down to the next report page, that means that it's now rendering. That means that I've made some changes to the table. So that table is now containing containing a lower amount of data. It's still a very large table. It's still a table that has, a lot of information in it. But because of the fact that I reduced the total numbers of records in that table, it renders significantly quicker. Because, for instance, now the table rendered in about 5 seconds, whereas we still haven't seen the overly detailed matrix. And the whole point I'm trying to make with this is if you're using tables, try to make sure that you're not putting too much data in there. And the fact that I'm seeing the scroll bar with a teeny tiny rectangle in there still usually means that the table is too large for humans to actually do something with this as well. Because if the answer is I want to scroll through it, or I want to print it, or I want to export it, then again, there are tools better equipped to handle those types of operations. Analyze in Excel, paging in reports, whatever you want to do with it. Those are typically better suited for working with large tables. Then, as I said, every single thing you put on the canvas has an impact. Every single thing we do on the canvas has an impact. And the one thing that people often forget are filters, are slicers. Sorry, I need to say slicers. And there are a couple of things that can happen with slicers. For instance, I've got some slicers. Oh, forgot to ungroup them. I've got some slicers on this page. And they also send back queries to the backend engine. They also need to be rendered. And now I've made them into a dropdown. But for instance, if I put them on a list page, that means that this list also has to be fetched and rendered whenever I open the report. So if you're seeing a report that has a bunch of filters, a bunch of slicers in there that are visually available, and they're in a list form, those are typically the things that I look at that actually have an impact on the performance that we're trying to do. And it means that it's something you need to be aware of it means that you need to be aware of this and potentially make these changes. So one thing to make it perform a bit better is by making sure that's in a drop-down format. The other thing what you can do is, and this is where the opinions are a bit spread, you can opt for a filter pane approach where you move the majority of the filters into the filter pane, but I know that not everyone is as big of a fan as the filter pane. The other thing that you can do is either drop the filters on a separate report page, where you can set the filters and have them synced back into this report page, or you can work with a collapsible slicer panel inside of the Power BI report page. I'll leave the decision making up to you, whatever suits your needs the best. I typically, whenever I used to design reports, I typically opted for the collapsible slicer panel approach, because it gives the end users the best. Well, it gives the end users the best options, as they don't have to click away to a separate page to change filters, to change slicers, etc. But you do have to be aware that there is some report maintenance in there. Phil, you're such a tease. Yes, that is the optimal way of working. Filter nothing and then just export the entire thing to Excel, only to hit the export limit. I think we're at, what's the export limit these days? 100,000 rows for export to Excel? I keep forgetting. I know that we have many different discussions to move them all to the Excel limit, but yeah, that's a different discussion. So filters is one thing that I need to be, okay, yeah, 150,000. So a question from David, I use a separate page with synced slicers. Is there a performance hit for those? Mostly no. Power BI is something, well, it uses, let's call it lazy or effective rendering. It only starts rendering the things that are visible on the report page. So if it's something that's hidden on the page, it's not going to be hidden. It's only going to start executing things if they are active on the slicer panel. If you are using slicers on a separate page, that does mean that the visuals that get executed, they take those filters into their filter context in DAX. So no, there's not a big performance hit on those things. But again, David, it's a matter of personal preference and whatever meets the business needs. Both of them can work, either with a collapsible slicer panel or with a separate slicer page. That is, like I said, completely up to you. So what I did is I took the lazy approach and I moved some of the filters down into the filter panel. And again, this is not a big change. It's just small, quick little things that are all compacting into one more bigger experience. All of the small things, they lead up to a bigger gain in the end. And then the last one is the map visual that I want to talk about for this one. The map visual is actually, well, it is a tricky one. I'm still using the Bing Maps visual for this one. I do need to make the switch over to the Azure Maps visual. But the map visual, what you need to be aware of is that every single one of these data points, they all need to be rendered. So that's about, I keep forgetting, that's about 300 individual circles that need to be rendered. So that means that typically maps are more visually intensive to render. And is that a good thing? Is that a bad thing? I'll leave that completely onto you, because I know that maps have specific sets of requirements for business users. The one thing that you need to be aware of is similar to all the other visuals, is the more of the data points you have to render, the more things that have to be done, the longer it's going to take for the thing to be done. And this is where the context and baseline that I referred to in the very beginning, that actually comes into play as well, because what's acceptable? What's the benchmark that they're trying to work towards? And then mapping itself is, well, that's where you need to make the decisions. What's the actual, what are the decisions that they hope to be driving from this visualization, and how fast does it need to be rendering? So for instance, I just quickly changed it over to a heat map, and because it's not rendering those small individual circles, that typically led to the fact that it's rendering faster as well, just by switching over to a heat map. Is a heat map an acceptable visualization for what your business users are trying to do? That's something I'll leave up to you. It is something that you need to be discussing with your business users and the requirements itself. But from opening up a Power BI report page that had about, well, let's call it as it is, that actually never rendered completely because the overly detailed matrix was still going, to a report that's opening up in, well, a couple of seconds. Is this as efficient as it could be? No, there's still optimizations that can be made. But these were a couple of quick changes that I actually did that led to some pretty good results in there. And then the other one that typically comes back, that's where we're diving into now, is what happens on the modeling side. And that's where I do lean into the external tools. But let's go in there. Go. The first one I want to mention is the tool created by our colleague on the Power BI CAP team called Michael Kowalski. And Power BI Report Analyzer is actually not that known, which is something that I think is a shame because it is pretty useful. The Power BI Report Analyzer, it actually takes the Power BI file that you have and then the performance data from the Performance Analyzer. And this is going to render you a visual overview of what the report is actually doing. Go. So what you need to do is select a folder where the report is located. Go. So what I need to put into that folder is a PBIX file or a PBIT file, the template file or the actual file. Then what you also need to have is the complete export of all the pages that you're looking at and the Performance Analyzer pane. So you need to click through every single one of the pages that you want to analyze and then export that data into a JSON file. You need to locate that. You need to put that JSON file into the folder that you're looking at, and then it's going to automatically pick it up. But what does it do is, if you look at the report itself that you've designed, that you've created, it's going to give you a sort of visual overview of the report itself. And it also allows you to go ahead and look at, okay, what are the visuals itself that are rendering slower, for instance? Because if you look at the DAX query time, that's where you can say, okay, I want to have anything with a total DAX query execution time of 0.8 seconds to be highlighted. So you can easily look at which of the visuals that are actually not working well. So if I take this back here, for instance, I need to do this one. That's where I can see that some of the shapes, some of the cards that I've been using with some of the time intelligence functions in there, they were more slower to be rendering as well. This is particularly useful if you have a report that you're not completely familiar with, and especially useful if it's a report that doesn't have proper titles or descriptions, etc. in there. Now, the big change that was introduced, well, a while ago already, is that inside of Power BI Performance Analyzer, if you click on one of the actions that are happening, it actually does highlight the visual that it's using. But in the early times, when it was initially released, it wasn't the case. So you had to figure out from the title of the visual that was being displayed which of the visual that it was. And if you then inherited a report from another developer that didn't bother naming their graphs, that could be, well, frustrating to say the least. But the beauty of this tool as well is that Michael, well, he's known pretty well for his best practices. He also put in some recommendations in here. And that's where he's actually going into a few things that can give you some good insights into what's happening. Because, for instance, he also highlights when you're doing filtering inside the visual, if you're doing some other different things. And again, this is pretty useful to just get an overview of pretty much, well, if you want to get a look and feel of what's actually happening in there. So I do encourage you to download this, to take it for a spin and use it on one of the reports that you're actually using, because it is particularly useful, like I said, to get the overview of what's actually happening in there. And then the other one that I want to highlight is probably pretty familiar to most of you. Tabular Editor, a tool created by Daniel Otekier, a Danish MVP, is, well, essentially, in my personal opinion, a tool that you have to have if you're trying to do something, well, if you're trying to build something large for Power BI. I specifically use Tabular Editor 2 because this is the free version, this is the open source version, so that you can do these exact same steps as well. You don't need to use Tabular Editor 3 for this. You can use it, but you don't have to use it. Specifically, for what I want to go at is, if I get a report, if someone asks me, okay, this is running slow, why is this running slow? What can be done to optimize this? Well, this is something where the best practice analyzer really comes into play. And if you want to look at the best practice analyzer itself, I'll drop this link into the chat window as well. Is Michael released a curated set of best practices a while back, and we're keeping it updated as we go. And it's essentially the whole runbook of things that we seem to be running into quite often. Some of the typical culprits for, well, degraded performances, for less optimal experiences itself. So it does contain a link in there to a couple of lines of code. And if you just execute these lines of code into the advanced scripting window, which I'll show you. If you execute these into the advanced scripting window, that's how you can load up the, I opened it already, okay. That's how you can load up these best practice rules yourself. There we go. So I copied over the links. You go into the advanced scripting panel, you paste in the lines of codes, then you execute it, close Tabular Editor, open it again, and then it's loaded in there. You will have them for as long as Tabular Editor is installed. So I have the model opened, that I was using there as well before. And this is where it gets really interesting, because with the single click of the button, I can get the entire overview of what's happening inside that model and what are some of the things that I may want to take a look at. And this is where it gets really interesting, because again, like I said, someone gives me a report. What can I do to change this? This typically gives us a very good overview of the things that we actually want to be looking at. And then some of the things that usually come up is the way that relationships are being developed. Are they using many-to-many? Are they using bidirectional filtering? Those types of things. Those are things that come up really quickly, and they give us a really good overview of things to start fixing. Michael also made sure that they are labeled as things that typically lead to performance issues, or if they're purely cosmetic, if they're purely on the maintenance side of the model. It makes it really easy to get that overview. The rules are being updated. I think we were also discussing some new improvements to best practices rules itself, so it's possible that we're getting some new rules in there. Especially with a couple of the features that have been released recently, like, for instance, hybrid tables, composite models, or direct query over analysis of services in Power BI datasets. That's where we're starting to get some new rules in there as well, because they have some different peculiarities, some different specialties that you need to be aware of as well. But long story short, run a best practice analyzer and work your way down into what are the things that you can do. So you don't need to tackle all of these at once, but again, it's the combination of little small changes that you're easily doing without actually breaking down into DAX queries or into Power queries that you can actually go ahead and start fixing things. So I'm not jumping into DAX Studio for the sake of time, because there are a few things that I want to be showing you, but I do want to make one final point about why I think star schemas are pretty darn useful for Power BI. So in general, you hear a lot of people shouting that star schemas or dimensional models, Kimball models, whatever you want to call them, are the way to go with Power BI. And I am one of those people as well. I specifically keep repeating that star schemas are the way that Power BI can do the best of its work with the engine internally. So this model itself is also designed as a star schema. We've got a central fact table, then a couple of small dimensions around it, and that's what's happening in there. And what is the impact of this? That's the question I typically get. The question I typically get on this. And the impact is something that I'll quickly show you as well. It's also very useful if it shows up on the correct screen. There we go. So this is essentially a bunch of CSV files. I think in total, it's about 20 gigabytes of CSV files that get loaded into Power BI Desktop. So 20 gigabytes of CSV files boils down to a model inside of Power BI. So the first thing I did inside of Power BI was just loading it in. Purely, that's the only thing. I also removed the data types that Power BI suggests automatically. So this is loading in 20 gigabytes of CSV files, just purely loading them in and having Power BI, having the Power BI engine, having the Power Query engine do their work. So that translates to roughly about a model persisted on disk of about 933 megabytes, which is pretty cool already, because that's some seriously good compression. But I can get it down a bit further as well. So by making sure that I just set the correct data types, that's also making a big impact already, because it's going down with, let's say, about 150 megabytes in total, just by switching over to the correct data types, integers, dates, etc., for whatever point it needs to be made. Then I disabled something that's called auto date time. And auto date time, I see Phil smiling already, is, well, it's a very useful feature that no one should use. It's a very loaded statement, but the auto date time feature is enabled by default. It means that if you do a new installation of Power BI Desktop, it's going to be enabled. That means that if you create a model, if you create a new Power BI file, it's going to look for every single field that is marked as a date time field, and automatically going to create a date table for you under the covers. And if you're a new user that doesn't know anything about DAX or Power Query, it's incredibly useful because you can just load it up in there, say it's a date, and then you can still use everything you need to be doing with year and month and day, for instance. But it does scan every single date that you have in the model and is going to create a virtual table, a calculated table for every date to the day level between the min and the max. So the lowest date and the highest date. Is that a good thing? Is that a bad thing? If you're a new user and you're working with a small Excel file, then no, it's not a bad thing. But the horror story called auto date time that I like to refer back to is when I was working with a customer, they used data coming from an ERP system. And ERP systems love dates. They had so many dates. I think the number was about 120 dates that were included in, Phil, 120 dates that were included in the Power BI model itself. The thing is that ERP system, they had the agreement that if a date was unknown, or if a date was not provided, then it was set to January 1st, 1900. If a date was still to be provided, then it was set to January 1st, 2100. So that means that for 120 date fields, 200 years of data were set inside of the data in the date table. So the model, they were struggling to load it. The model was too big. It wasn't refreshing well, etc. It was going slow. So that's why they called me at the time. So the model itself, the data set size itself, was about 9.5 gigabytes. The second I flipped off auto date time, well, I switched off. I mustn't say flipped off because I know that some people have a different connotation for that. The switched off the auto date time, that means that the model size itself, because it wasn't doing all those different types of, all those DAX calculated columns, it dropped down to about 120 megabytes. So that's just by switching off one little option, and that's auto date time. And as I said, it's a great feature. It's a very beautiful feature that no one should use, because if you're doing something more serious, that's when you need to create your own proper date table and use that for the operations that you're trying to use. Because in that case of the ERP system, they were only actively using 2 dates in their reporting scenarios as well, which means that they were doing some pretty drastic operations. So by switching off the auto date time function, we're going down a bit as well. And then it brings me down to the other one, is unused columns. There were a bunch of columns in that model that were never going to be used for any of the reporting purposes. If you're not using them, you shouldn't be putting them in the model because it takes up space, it takes refresh time, and it just makes the whole model less overviewable as well, which is something you really need to be aware of. And then we get down to the final one that is making the biggest difference. I modeled it as a star schema. Every one of them before that was just one giant table as if it were a CSV file. And that's where the really big difference comes in, because we're going from about a model that's 933 megabytes to a model that's about 140 megabytes just by going down to a star schema, which means fact table dimensions and having Power BI work its magic. And why is this such a big deal? Well, the model is smaller, which typically leads to the fact that it's going to be easier to read and scan the data that needs to be returned, and that's going to be a better experience overall. The thing that you have to be aware of is that refresh time is slower because of the fact that I was just dumping in a CSV file and not doing anything with it. It does mean that there are refreshes, that the refresh has to do some operations, it has to do some transformations, and that's going to have a hit at refresh time. But usually we only refresh once or twice every single day. And that means that we do the waiting once or twice every single day instead of having the end users wait whenever they're trying to query these things. Then the last one was just for the fun of it. I created a calculated column in there. And a calculated column is something that is also one of my culprits whenever I look for optimizations. Why is this? Is a calculated column, they get processed after the data is being loaded into the model. So you have Power Query doing the transformations, it loads the data into the data set itself, into the model, and then the calculated columns get executed. So that means they're not optimized as well as the data that we have persisted in the model, and it also means that it's going to make the refresh time a bit slower. So by just making one extra calculated column that just said, I think I just did a divide the, I think I just made the trip time up to the second level instead of the minute level, and that adds a bunch of data in there as well. That's going to be, well, the data set's going to be bigger, the refresh time is going to be longer, etc. And the whole spiel of this, the whole point of this is that I typically try to make to people is most of the scenarios that you're trying to do inside of a calculated column, well, they are typically going to be able to be done inside of Power Query or inside of your data source. That's going to be a very easy thing to do. There are some certain scenarios where calculated columns are really useful, but then you have to be aware of the what, why, and how, I think. Typically, my opinion is don't try to use calculated columns because you're more easily able to solve these things in the steps before that. Or if I want to say it as eloquently as my colleague Matthew Roach, is data should be transformed as far upstream as possible or as far downstream as necessary, which basically means if you put your data transformations earlier, that's where they're typically going to be done more efficiently as if you're doing them in calculated columns at the end of the chain. Okay, so there we go. One last thing that I want to show you is something that is often overlooked. So I mentioned that the hardware works. The hardware plays a big role as well. And that's something I'm not saying very lightly. So Chris Hamill, one of my other colleagues on the CAT team, one of the US colleagues, he made a, well, I'm calling it an evergreen tweet these days because it's been posted quite a while ago already. It's been in August 2019, but the entire thing is still very valid. Chris is making the point where the browser that an end user uses has a very big impact on what you're trying to do. And in the case that he made at that point in time, there was still a difference in between the Edge dev versions, which was running a Chromium-based kernel, or the Edge browser, which didn't have that at the time. Right now, it does have that, so the Chromium kernel. And it means that just by using the same machine, the same report, the same model, etc., the browser window itself actually gave about a 15-second difference. So the choice of the browser, the choice of the hardware, whatever you're doing with your end user has a very big difference. So typically what I see is that everything that's running on a Chromium kernel, which is Chrome, which is Edge, they typically do very well. Firefox, Mozilla Firefox has a smaller impact. And if you're running Internet Explorer, then yeah, sorry, but you're not going to have a very good rendering experience on that. There we go. And that's could be faster though. I'm not completely sure what you mean with this, Katie. Can you elaborate? Yeah, I'll wait for Carrie to be done.
Just on that point, Benny. One thing about browsers is when you load a report page in a browser from the web service, the protocol version, HTTP 1.x versus HTTP 2 can make a big difference.
Yeah.
And you can press the F12 button and actually see, you can add the protocol line. Because if your browser is running HTTP 1.1 or 1.0, it'll only ever attempt to render 6 at a time. And so if you've got more than 7, it can stick out like a sore thumb. But if you have got HTTP 2 end to end, the service detects that, then every visual can load simultaneously, and then it just becomes how much CPU have you got on your machine locally to be able to, do all this drawing, for example. And I've seen situations where the customer's browser goes through a corporate internal proxy or firewall, and that can be enough to sort of step it down to 1.1, and the user might go home and try it on their same version of the browser, modern browser, and loads so much quicker, and it can be down to things like that sometimes too.
Yeah, absolutely. And I mean, that particular example is something that we're still investigating, Rui, Chris, and I. The overall plan is to get something published as soon as we finish the total findings on that. But you're absolutely right that that also has a very big impact. And Kerry, I do agree that it's still a long time to render. This was just a report that Chris made that is explicitly visually intensive at the time in 2019. So he can make his point. But it is still a long time to render. I completely agree with this. So I do have a lot more stuff to go through, but for the sake of time, let's call it now, because what I usually go into now is a bunch of best practices and guidances. So I will drop a link to the slides into the chat window as well. And then what I do want you to be aware of is that I included a bunch of resources in the slide deck as well for you to use and to refer to. But for the sake of making sure that I wrap up and emphasize the key points that I think are very important to take away from this, is that it's always better to think of these report design and report performance issues at design time. There are some things that you can keep in mind that are actually going to end up saving you a lot of time in the future, because it's easier to think of these things, to try out a few things when you're still designing and when you're still developing that report. The second it goes into end user hands, it gets harder to change something, because we're all human. We're not that fond of change, especially some of us. It means that we can more easily make the right decisions when it's still being developed and still being worked on initially. What I want you to be doing as well is make sure that you're thinking about where you're transforming the data. Transforming the data as far upstream as possible, making sure that it can be done in the most efficient way there. Modeling is key. I mean, star schemas, they make a very big impact on the overall performance, on the data set sizes as well, and they genuinely make Power BI do the best of its work. That's what you need to be aware of. Star schemas are a very good way of working these things. Then, if you get some reports by your end, if you get some situations that are being reported by your end users, try to have some insights onto what type of browser, what type of hardware they're running. The thing Phil mentioned about the HTTP proxies, etc. Those are some things that can be a very big impact as well, without the model actually being the thing that you need to look at. And then what I typically also try to advise is that you have Tabular Editor. Make sure that you look into Tabular Editor and get an overview of the rules that exist in there, and try to figure out which ones matter for you the most for the reports and the models that you're actually trying to work with. And then, try to learn new things, read public documentations, read online resources. There's a lot of great content being published by people in the field, by MVPs, by Microsoft employees. There are lots of useful things that you can do in there. And then the guidance docs, the guidance documentations is a very good starting point for you to go to if you're actually looking for some things to go into. There's a bunch of resources in here that you can refer to that I typically try to use. And then if you want to have the slides, then you can get these slides on the link that I just shared into the chat window as well. And with that, that's all I had.